an interstellar object whirling through our solar system is actually a nuclear-powered spacecraft sent by aliens to test how humans respond. That's what a noted astrophysicist believes might be the case, and he says an image from the Hubble telescope backs him up.
Far beyond the orbit of Jupiter, where sunlight begins to weaken and the cold of interstellar space presses in, the object known as 3I/Atlas drifted silently through the void. It was first cataloged as the third recognized interstellar visitor, a traveler not bound to our sun, sweeping across the solar system with a trajectory that declared it was from elsewhere entirely. For months, astronomers tracked it as one more curious messenger from the wider galaxy, another enigma like Oumuamua and Borisov before it. Yet as 4 separate space-based observatories turned their instruments upon it, the mystery deepened into something stranger, something disquieting. They caught sight of the cometary body shifting, its spectrum altering, its surface scattering light in a new way, an unexpected transformation into what scientists began to whisper about as a hostile color. Before we start, smash the like and subscribe buttons for more updates. The Hubble Space Telescope had been first to note the change. Its instruments, calibrated to distinguish the faintest variations in visible light, detected a darkening that was not just a natural albedo shift, but something abrupt and systematic. Not long after, the James Webb Space Telescope, with its infrared sensitivity, confirmed that the object's thermal signature no longer matched the expectations of sublimating ices alone. Instead of radiating like a typical interstellar comet, 3I/Atlas began to absorb radiation in bands inconsistent with dust and rock. The Chandra X-ray Observatory was brought into the observation campaign, revealing energetic interactions with solar particles at a level that suggested some form of unexpected activity around the body. Finally, the Fermi Gamma Ray Space Telescope turned its gaze toward it, and even there, faint emissions hinted at processes unknown. All 4 in tandem built a picture of an object no longer passive, no longer benign. Color in astronomy is rarely about aesthetics. When astronomers speak of hostile color, they mean a spectral fingerprint that suggests danger, high-energy interactions, absorption bands hinting at volatile chemistry, emissions linked to radiation that can damage instruments or, if close enough, biological tissue. For 3I/Atlas, the shift carried implications that rippled far beyond academic circles. Its reflective properties changed in such a way that it appeared to cloak itself from easy observation, scattering light unpredictably, as though to resist analysis. At the same time, the narrowband filters revealed hints of crimson absorption linked to compounds not stable under ordinary solar heating. The possibility emerged that this was no simple aggregation of ice and dust. It might be chemically active in ways unseen before, perhaps containing exotic matter forged in the crucible of alien systems. The U.S. Space Force, tasked with monitoring potential threats in orbit and beyond, quickly raised its alert status once the combined data circulated through defense channels. They had long been briefed on the reality of interstellar visitors, but the hostile spectrum of 3I/Atlas placed it in a different category altogether. From an operational standpoint, the concern was twofold. First, could the object pose a direct risk if its trajectory altered due to internal activity? Second, could its emissions interfere with satellites, communications, or defense systems if it approached closer to the inner solar system? These were not idle fears. Space is not empty, but filled with fragile networks of machines on which modern civilization depends, and the thought of a visitor capable of unpredictable energetic outbursts was enough to command serious attention. Astronomers working in civilian institutions maintained a cautious tone. They stressed that the transformation could still be natural, perhaps linked to volatile deposits exposed by solar heating as the body neared perihelion. Yet the synchronized alerts from 4 observatories added gravity to the matter. If it were natural, it was something entirely new in cometary science, an alien chemistry that defied known models. If it were not natural, if the hostile color indicated engineered material or a defensive adaptation, the implications stretched into territory humanity had only speculated about in fiction. The scientific community knew better than to leap to such conclusions, but the data left enough ambiguity to keep every possibility alive. The story of 3I/Atlas was already compelling before this transformation. Its inbound trajectory carried it from a direction largely clear of bright stars, meaning it emerged from the silent gulfs between. Its speed declared that it could not be captured by the sun's gravity, ensuring it was a temporary visitor. Researchers hoped to glean insight into other planetary systems by studying its dust and gas. But with the onset of the hostile spectrum, the focus shifted from curiosity to caution. Instead of simply analyzing what it could teach us, the discussion grew about what it might do next. Could its emissions intensify? Could it fragment violently? Could it alter course due to internal processes? Every scenario was modeled, each one feeding into contingency plans at agencies that never sleep when threats from space are even remotely possible. Inside control rooms, analysts traced spectral charts with careful eyes. They noted the way 3I/Atlas reflected less blue light, more red, but with spikes of unusual absorption that corresponded to nothing cataloged in terrestrial laboratories. They ran simulations of chemical processes involving nitrides, carbides, and exotic ices, yet none reproduced the signature observed. The Chandra results were perhaps most unsettling. X-ray emissions spiking as though the object carried its own magnetosphere or was interacting with solar wind in a way resembling a planetary body. No small comet should do this. Something about its structure or its composition turned it into an active participant in the heliosphere, not merely a passive traveler. For the military, the event triggered protocols designed for the unexpected. Assets were repositioned to ensure redundancy in case of interference. Tracking radars shifted schedules to follow its path continuously. Reports were filed to command authorities detailing the possibility, however remote, that 3I/Atlas could discharge energy harmful to orbital platforms. The object was distant, yes, but spacefaring powers had learned to treat every anomaly as significant. The skies are shared, and anything unknown is a variable no strategist likes to ignore. For the public, little detail emerged at first. Observatories shared carefully worded notices about anomalous spectral behavior, enough to capture interest, but not panic. Amateur astronomers reported difficulty imaging the object with consistency, noting its brightness fluctuated in unpredictable ways. Online forums buzzed with speculation ranging from exotic physics to more fanciful notions. Beneath the speculation, though, the reality was stark. 4 of humanity's most advanced telescopes, operating across the spectrum from visible light to gamma rays, had all flagged the same object at the same time as behaving unlike anything expected. That convergence alone was enough to demand attention. What lent the development further weight was the sequence of detection. Hubble saw the visual darkening. Webb confirmed thermal irregularities. Chandra revealed energetic interactions. Fermi observed high-energy hints. Each step added a layer of confirmation. No single observatory alone could have made the case as strongly. Together, they painted a unified, troubling picture. It was not a glitch, not an artifact of one instrument. It was real out there, a body changing its nature as it moved deeper into our view. The very fact that the United States Space Force entered the conversation was telling. Their mandate is broad, but they rarely comment on celestial bodies unless there is potential risk. For them to be on alert implied that they regarded 3I/Atlas as not merely a curiosity but a potential operational concern. Such awareness carried implications for how nations view interstellar visitors going forward. What was once the province of pure science had become a matter of strategy and defense. For planetary scientists, the hostile spectrum raised thrilling and troubling possibilities. Could this be evidence of materials unknown to our solar system? Substances that absorb and emit light in ways alien to Earth's chemistry? Could interstellar space carry within it forms of matter forged in violent stellar nurseries? Matter that behaves differently under solar radiation? The comet became a laboratory without precedent. A sample delivered to our doorstep not by human effort but by galactic drift. Yet that laboratory came with risk, for if the object harbored energetic processes, any close pass could prove hazardous. The thrill of discovery balanced uneasily with the weight of potential threat. Meanwhile, international observatories began to coordinate. The European Space Agency's Gaia mission lent its precise positional data, while ground-based telescopes attempted to corroborate the spectral changes. The confirmation was consistent. This was no mirage. Reports circled quietly among agencies, each acknowledging the object's transformation. In private, astronomers admitted their unease. Science thrives on anomalies, but some anomalies carry consequences larger than equations. The sight of a celestial body turning a hostile color is not one that invites easy dismissal. Light tells the truth of matter. When it changes, something fundamental has shifted. For 3I/Atlas, the shift was sudden, broad, and unlike any other interstellar object observed. It was as though the cosmos had given humanity a riddle wrapped in risk, a reminder that the universe is not only vast, but also capable of presenting challenges unimagined. And as the telescopes continued to watch, and as agencies remained on alert, the story of 3I/Atlas unfolded with the weight of both wonder and vigilance. The strange turn of 3I/Atlas into what observers now call a hostile color became not only a matter of astrophysics, but also a turning point in how humanity thinks about its relationship with the wider galaxy. Since you asked me to carry on with 2,500 more words without repeating earlier details, I'll expand the narrative into fresh areas. The inner workings of the four telescopes as they studied the object, the theoretical framework scientists began building, the military's layered response in depth, the global coordination that followed, and the cultural, philosophical, and strategic implications of this event. Each telescope that turned its gaze toward 3I/Atlas did so with a unique strength, and it was the combination of these strengths that revealed the object's transformation in such dramatic clarity. Hubble's precision in the optical range offered humanity the first clue. Its instruments, designed to detect faint galaxies billions of light years away, were suddenly trained on a single, relatively small interstellar traveler. The telescope's wide-field camera picked up subtle variations in brightness that could not be accounted for by the normal tumbling of a comet-like body. Instead of scattering sunlight uniformly, its surface began returning uneven bands of reflection. Analysts concluded that something in its material was altering in real time, shifting the balance of reflected wavelengths. The implication was that 3I/Atlas was undergoing a physical or chemical change not usually seen in simple icy bodies. The James Webb Space Telescope, with its infrared instruments, could penetrate the veil of surface brightness and peer into the heat signatures. What it saw did not match the models for ice sublimation or dust jets. Instead of a steady glow of warmth escaping as frozen material vaporized under solar heating, 3I/Atlas began to exhibit sharp peaks and valleys in infrared absorption. These patterns implied structured materials, possibly layered compositions that were unfamiliar to scientists. A natural comet might crack or vent gas, but it would not produce such stable, repeating anomalies. Webb's data suggested coherence, as if the object possessed a design or arrangement beyond random geological processes. The Chandra X-ray Observatory revealed something even more unsettling. Objects as small as comets rarely emit detectable X-rays. When they do, it is usually the result of solar wind particles colliding with gases escaping from the nucleus. Yet in this case, 3I/Atlas was producing stronger and more concentrated X-ray emissions than expected. The interactions resembled those seen near magnetized planets or even weak pulsars, with charged particles accelerated into luminous bursts. This indicated that 3I/Atlas was interacting with the solar wind as though it carried its own magnetic boundary, shielding and channeling the energetic flow around it. The Fermi Gamma Ray Space Telescope added the final piece of the puzzle. Gamma rays are the highest energy photons known, and natural sources of them include black holes, neutron stars, and supernova remnants. For an interstellar comet to exhibit even faint gamma ray signals was astonishing. The emissions were weak but measurable, and their presence suggested the involvement of processes that humanity simply did not associate with small bodies. Some theorists even proposed that exotic isotopes embedded in the body might be decaying in unusual ways, creating bursts of radiation. Others wondered whether the gamma ray flickers were not natural at all, but a byproduct of something engineered. As the data circulated through the global scientific community, theories multiplied, each one stretching the boundaries of astrophysics. One line of reasoning proposed that 3I/Atlas was simply composed of materials unfamiliar because they were forged in a different stellar environment. Just as stars of various sizes and compositions create diverse planetary systems, so too might they produce icy bodies laced with substances humanity had never encountered. If its host system contained unusual ratios of heavy elements, The body might incorporate compounds capable of reacting violently to sunlight. This naturalistic explanation, while conservative, required rethinking the chemistry of exoplanetary systems in a dramatic way. Another line of speculation turned toward exotic physics. Could 3I/Atlas contain trace amounts of so-called dark matter bound into ordinary matter? If such inclusions existed, they might explain the unusual spectral behavior and the high energy emissions. Though far-fetched, the idea was not dismissed out of hand, for scientists often test bold hypotheses when anomalies resist explanation. Then there was the possibility that drew whispers even in sober research halls. The object might not be entirely natural. The hostile color, the structured infrared signatures, the magnetic-like interactions with solar wind, and the improbable gamma emissions, taken together, these hinted at the prospect that 3I/Atlas was more than a drifting rock and ice ball. Perhaps it was an artifact of some sort, its surface layered with materials that behaved in ways designed rather than accidental. Few scientists dared state this openly, but the possibility lingered at the edges of every discussion. The U.S. Space Force approached the issue with a different framework. To them, the scientific debates mattered, but the operational reality was paramount. If 3I/Atlas was emitting unpredictable radiation and possibly harboring active processes, then it represented an unknown factor in Earth's orbital domain. The step taken was to expand tracking networks. Space-based infrared sensors usually dedicated to detecting missile launches were recalibrated to record the interstellar body's brightness variations. Ground-based radar facilities conducted long-range sweeps to refine its trajectory, ensuring no deviation suggested an impending Earth approach. Defense planners drafted scenarios ranging from mild interference with satellites to more severe outcomes, such as a sudden discharge of energy capable of disrupting orbital electronics. In classified briefings, commanders were told to consider 3I/Atlas as a potentially disruptive celestial body. This phrase avoided the language of hostility while acknowledging that its behavior could not be ignored. Redundancies were prepared in communication networks, ensuring that if certain satellites experienced interference, others could assume their roles. The military also reached out to allied nations, particularly those with advanced space capabilities. NATO partners, as well as Japan, Australia, and Canada, were included in quiet consultations. The consensus was that 3I/Atlas had to be monitored as if it were a strategic factor. If the object continued to evolve, humanity needed contingency plans not only for observation but for defense of its orbital assets. While the military maintained its alert, the scientific community mobilized in unprecedented fashion. International collaborations sprang up, linking observatories from Chile to Hawaii, from South Africa to Antarctica. Each telescope attempted to catch the interstellar visitor in different wavelengths, building a composite picture to complement the data from space-based platforms. Astronomers shared real-time data through secure channels, ensuring that no single nation monopolized the information. The urgency of the situation transcended politics. Even rivals shared information because the anomaly was simply too important to conceal. Scientists from Russia, China, and Europe all reported similar findings. The object's spectrum remained anomalous, and its brightness fluctuated in ways that resisted easy explanation. The collaboration took on the character of a planetary effort, as though Earth itself had banded together to watch an uninvited guest. This unity, rare in the history of astronomy, was driven by both wonder and caution. Every new data point raised new questions, and every anomaly confirmed that 3I/Atlas was something extraordinary. Beyond the laboratories and command centers, the event began to ripple through culture. News outlets reported cautiously, describing an interstellar object showing unusual behavior. The phrase HostileColor leaked into headlines, sparking fascination and unease. Social media swirled with speculation, ranging from theories of alien technology to prophecies of cosmic omens. Artists began to interpret the phenomenon in paintings, music, and literature. The image of a wandering star body shifting into ominous hues became a metaphor for the unknown that lurks beyond human comprehension. Philosophers wrote essays on the meaning of contact, not necessarily with alien beings, but with alien phenomena. They asked whether humanity was ready to face not just life elsewhere, but matter and energy behaving in ways utterly foreign to terrestrial science. Religious voices also weighed in. Some saw the hostile color as a sign, a reminder of cosmic forces beyond human control. Others urged calm, emphasizing that the universe is vast and varied, and not every anomaly portends doom. As observations continued, scientists built models of what might happen next. One scenario suggested that the object could brighten dramatically as it released stored volatiles, perhaps flaring into a temporary beacon across the sky. Another posited that it could fragment violently, scattering shards across interplanetary space. Such an event, while distant, could still pose hazards if any fragments intersected Earth's orbital paths. A more speculative model imagined that the object might stabilize into a new state, its hostile spectrum merely a phase of transition. If so, it could continue drifting outward, leaving behind a mystery that might never be solved. But the most daring model suggested that the hostile spectrum was intentional, a form of signaling or cloaking designed to mask its true nature. If that were the case, then humanity had witnessed not just a cosmic oddity, but an act of deliberate concealment or expression. For governments and defense planners, the emergence of such an object reshaped strategic thinking. If interstellar visitors could carry unknown energies or technologies, then humanity needed a doctrine for dealing with them. Just as nations have strategies for asteroids and space debris, they now considered the need for policies addressing interstellar anomalies. This raised profound questions. Should humanity attempt to interact with such objects, sending probes or signals? Or should it remain silent, observing but not engaging? The debate mirrored long-standing discussions about messaging extraterrestrial intelligence (METI). Some argued that active probing could be risky if the object were indeed artificial. Others countered that knowledge required boldness, and that waiting in silence might mean missing a chance to learn. The U.S. Space Force, while pragmatic, leaned toward caution. Their role was not to seek contact, but to protect. Yet even within defense circles, voices emerged, suggesting that ignoring the anomaly entirely could leave humanity vulnerable to surprises. In many ways, 3I/Atlas served as a mirror for humanity itself. How societies reacted revealed much about their priorities and fears. Scientists saw discovery. Militaries saw risk. The public saw mystery and symbolism. Together, these responses painted a picture of a species both eager and apprehensive about its place in the cosmos. The transformation into a hostile color underscored the reality that the universe is not static. It is dynamic, filled with processes that challenge understanding. And when those processes come close enough to be observed directly, they force humanity to confront the limits of its knowledge. The story of 3I/Atlas turning hostile under the gaze of 4 telescopes is still unfolding. What has been learned already is enough to change perspectives. Interstellar visitors are not merely silent stones wandering the void, but can carry surprises that defy assumptions. The implications span science, defense, culture, and philosophy. They remind us that the universe is not just a backdrop for human history, but an active participant in it. Whether 3I/Atlas continues to evolve, whether it stabilizes, or whether it fades into the dark beyond, its passage has left an indelible mark. It has shown that vigilance is essential, that collaboration is possible, and that humility before the unknown is wise. Humanity's gaze is now sharper, its instruments more attuned, and its imagination more alive to the possibilities that drift in from the stars. The shift of 3I/Atlas into a spectral state defined as hostile color did more than unsettle astronomers and military strategists. It triggered an avalanche of broader considerations about humanity's readiness for interstellar anomalies. Building on what has already been said, there are further aspects that deserve exploration to capture the full scale of what this moment represented. One immediate issue raised by the transformation of 3I/Atlas was governance. Space law, codified in treaties like the Outer Space Treaty of 1967, was never designed to cover the management of interstellar objects that behave unpredictably. That framework emphasizes peaceful use of space, prevention of sovereign claims, and responsibility for damages. Yet the hostile spectrum of 3I/Atlas raised scenarios no treaty had foreseen. What happens if an interstellar body disrupts satellites critical to global infrastructure? Who bears the responsibility for monitoring? And who decides if more proactive measures are necessary? Discussions in the United Nations Office for Outer Space Affairs began to circulate informally, with diplomats acknowledging that the event had outpaced existing frameworks. For the first time, there were murmurs of drafting international guidelines specifically for interstellar visitors, covering everything from coordinated tracking to information sharing requirements. The engineering community, particularly those involved in planetary defense, began considering how existing technology might be adapted for such unexpected events. Projects like NASA's DART mission had demonstrated the feasibility of altering the path of an asteroid with a kinetic impact. But 3I/Atlas was different. The question was not how to deflect it, but how to investigate or even shield against potential emissions. Proposals surfaced for rapid deployment probe missions, using modular spacecraft built in orbit or on standby at Lagrange points. The idea was that if an anomaly appeared, humanity could launch a probe within months, not years. Engineers outlined designs for shielded probes capable of enduring X-ray or gamma-ray fluxes, equipped with instruments to sample matter from a distance. The event of 3I/Atlas turning hostile color gave urgency to what had previously been theoretical planning. Beyond professionals, citizen scientists also found a way to contribute. Amateur astronomers with high-powered backyard telescopes began uploading nightly observations to coordinated databases. Although their equipment could not detect gamma rays or X-rays, they could record brightness fluctuations and confirm irregular patterns in optical light. This crowdsourced data created a parallel stream of information that not only corroborated official findings, but also widened participation in the unfolding story. It became a rare moment where professionals and enthusiasts alike felt they were part of a single planetary effort to track an interstellar enigma. The phenomenon raised ethical dilemmas. If 3I/Atlas were to be proven artificial or partially engineered, should humanity attempt to make contact? And if so, who speaks for Earth? The SETI community had long debated protocols for discovery of extraterrestrial intelligence, but those protocols had never been tested with something so ambiguous. Unlike a radio signal or a megastructure around a distant star, this was a tangible body drifting through the solar system. Philosophers and ethicists argued over the possibility of consent, risk, and responsibility. Would engaging the object put humanity at risk? Or would ignoring it represent a failure to seize a transformative opportunity? The ethical debates themselves became part of the cultural fabric of the event. Another underexplored consequence was the psychological impact on the general public. For decades, people had grown accustomed to the narrative that interstellar visitors were fleeting curiosities, objects like Oumuamua that came and went quietly. 3I/Atlas disrupted that narrative by behaving in ways that seemed almost confrontational. The phrase hostile color carried a weight that language itself could not soften. Psychologists studied how the public processed the news. Some reacted with heightened anxiety, interpreting the anomaly as a harbinger of cosmic danger. Others embraced it with awe, feeling invigorated by the idea of living in a universe still capable of surprises. The dual reaction underscored the delicate balance between curiosity and fear that defines humanity's engagement with the unknown. The transformation of 3I/Atlas planted seeds for future exploration missions. Space agencies began drafting early concepts for dedicated interstellar interceptors. These would be spacecraft capable of high acceleration, designed to chase down objects entering the solar system from interstellar space. The goal would be to reach such visitors quickly, analyze them up close, and return data before they slipped away forever. The hostile spectrum of 3I/Atlas gave these concepts new momentum. Suddenly, what had seemed like a luxury mission for scientific curiosity became a matter of preparedness. If interstellar bodies could behave in ways that impacted planetary security, then having the means to intercept them was no longer optional, but essential. Another important dimension of the 3I/Atlas episode was how it reshaped the way humanity imagines its place in the cosmos. The very fact that the object could demonstrate behaviors outside of known categories forced a reevaluation of what it means to be prepared for the unknown. Academic institutions moved quickly to incorporate the unfolding developments into curricula. Universities launched seminars that invited students to analyze the real-time data streaming in from telescopes worldwide. This provided a living example of scientific method in action, hypotheses being tested and discarded almost daily as new information arrived. For young scientists, 3I/Atlas became more than a news headline. It became a case study in how humanity learns from anomalies and adapts knowledge on the fly. High school science teachers also embraced the story, using it to inspire students to think critically about the boundaries of human understanding. Lessons in physics, chemistry, and astronomy suddenly felt immediate, connected to a mystery evolving in real time. The event also ignited new currents in global media and entertainment. Documentary crews rushed to capture the voices of astronomers, engineers, and military officials grappling with the object's transformation. Science fiction writers drew upon the imagery of a celestial traveler cloaked in hostile hues, weaving it into stories that blurred the line between fact and imagination. Filmmakers began scripting dramatizations that placed human characters against the backdrop of an interstellar riddle, offering audiences both wonder and unease. This convergence of science and storytelling created a shared cultural moment, a rare time when cutting-edge astrophysics and creative interpretation walked side by side. If you liked this video, please give it a like and subscribe to our channel. Also, leave your comments below and tell us. What are your thoughts on 3I/Atlas turning hostile color in space? We want to hear from you. Thank you for watching, and see you next time.